Are you superhuman when it comes to probability? Try to beat these 3 riddles. Ready? Go! Doctors have developed a highly accurate HIV test. It gives the wrong result just 1 out of every 100 tests. One person is picked out of a crowd and given the test. The result comes out positive. What's the likelihood that this person actually has HIV? Most people would say, pretty likely. With such a high level of accuracy, it makes sense that the test result would match reality. It turns out, the real answer is actually only 33%. That's just a 1 in 3 chance that a randomly tested person actually has HIV. Why do we get this wrong? Well, it's not because the test isn't accurate. What most people fail to consider is that only 1 out of every 200 people in the world actually has HIV. In contrast, since the test gives the wrong result 1% of the time, we can expect 2 out of 200 people to receive a positive result, even though they don't actually have the virus. This means that the tiny chance that the test would falsely give a positive result is outweighed by the even tinier chance that one person chosen at random would have HIV. How about a different problem? Imagine there are 2 boxes in front of you, both full of red and blue balls. You know that one of them has 2/3 red balls and the other 2/3 blue balls, but you don't know which is which. You choose one of the boxes and start pulling out balls one at a time. Each time you pull out a ball, you write down its color and return it to the box. After the 50th time, you count that 30 of the balls were red and 20 were blue. What's the likelihood that this is the box with more red balls than blue? Most people estimate around 60 to 80% likely, but actually it's 99.9% likely that this was the box with more red balls. The reason we tend to underestimate this likelihood is because it's hard for humans to intuitively understand the weight of accumulated evidence. Think of each time a ball is drawn as one snowflake. Individually, not very conclusive. But when enough of them accumulate, they together have a much more substantial weight. Let's try one more. Now imagine the same 2 boxes back from the previous riddle. You don't know which one has 2/3 red balls and which has 2/3 blue balls. But this time, after you choose one of the boxes, somebody else takes the box away and hides where you can't see what's happening. Each time this person pulls out a ball, she tells you whether it's red or blue, and then returns the ball to the box. The catch is, she doesn't always tell the truth. When she pulls out a red ball, she tells the truth 100% of the time. But when she pulls out a blue ball, she tells the truth only 80% of the time. The other 20% she lies and tells you she pulled out a red ball. After 50 times, she's reported red 30 times. The same numbers you counted in the previous riddle. What's the likelihood that she was pulling balls out from the box with more red balls than blue? Just this small change in the riddle leads to a very different result. Even though she reported red the majority of the time, it's now actually more likely that the box is the one with mostly blue balls. To be precise, it's just 42% likely that the box you chose was the one with 2/3 red balls. What does this tell us? If understanding the combined meaning of all the accumulated snowflakes is difficult on its own, the addition of unreliable reporting to the mix makes it even harder. When we're not sure how likely something is in general, what the combined effect of all the accumulated evidence is, or how reliable the reports are, it makes it almost impossible to get an accurate, intuitive understanding of what it all means. These 3 riddles demonstrate how fragile human intuition is. But the situations in the riddles are still far less complex than the messy, uncertain issues we encounter in the real world. Was the jury right to give that guilty verdict? Are vaccines safe? Which of the contradicting war reports are true? What happened to an airplane that disappeared without a trace? What if we had a way to overcome our fallible human intuition? Now we do. Rootclaim is a super intelligent investigative reporting platform that lets us get to the bottom of complex issues without falling into the traps of faulty reasoning. Rootclaim doesn't cherry-pick the evidence. Its proven probabilistic engine calculates the combined effect of all the evidence from every side of the issue. The entire process is crowdsourced, so every piece of the analysis is completely transparent and open to scrutiny. Finally, there's a way to harness our collective knowledge in an objective, mathematically sound way, letting us get to the root of real-world issues that matter.